Good day, everyone.
I am Graciela Makalintal.
And I am Therese Gadi. We are from MAKATI Science High School, Philippines, presenting our study entitled Utilization of Sweet Potato Starch for the Synthesis of Biodegradable Plastics.
Background of the study.
Petrochemical-based plastics such as polyolefins, polyesters, polyamides, etc. have been increasingly used as packaging materials because of their availability in large quantities, at low cost and favorable functionality. Characteristics such as good tensile and tear strength, good barrier properties, aroma compounds, and heat sealability. The problem with conventional plastics is that they take decades to degrade in nature and are produced by non-renewable sources like petroleum, coal, and natural gas. They also have very low water vapor transmission rate. Biodegradable plastics are polymeric materials capable of decomposing when given an appropriate environment and sufficient amount of time. Nowadays, new types of biodegradable plastics with improved properties and lower costs have been developed. Bastioli showed that nearly all biodegradable plastics available in the market are derived from starch, either from starch-based materials such as slightly modified starch, alone or complexed with natural or synthetic biodegradable polymers, or from polylactic acid which originates from the fermentation of a starch feedstock. Sweet potato is a fleshy edible root crop and is usually grown in the Philippines. Sweet potatoes are high in dry matter and a good source of energy, carotene, niacin, thiamine, and riboflavin, and starch makes up the nutritive reserves of certain minerals.
This study was conducted to produce biodegradable plastics from sweet potato starch. The use of biodegradable plastics in place of some of the conventional plastics present today can help reduce pollution, which can lead to the demise of global warming and climate change.
Of the problem.
Main question: can the starch from sweet potato be able to produce a biodegradable plastic? Specific questions: what are the properties of different samples of the biodegradable plastics in terms of color, texture, elasticity, tensile strength, biodegradability, and stain resistance? Is there a significant difference among the different samples of biodegradable plastics in terms of its properties except biodegradability?
Significance of the study.
Reduce buildup of plastic in landfills.
Reduce the use of crude oil in plastic manufacture.
Put unused sweet potatoes into good use. Help increase the livelihood of sweet potato farmers.
Scope and limitations of the study.
The researchers will only produce bioplastics made with sweet potato starch as a base. The starch used will be extracted from uncooked sweet potato flesh. Lastly, the researchers will only measure the plastic's color, texture, elasticity, tensile strength, biodegradability, and stain resistance.
Review of related literature.
According to Bauer, sweet potatoes are starchy root vegetables. Starchy vegetables contain variable nutrients, but they can also be used to make biodegradable plastics. Marzo and Duhay Longsod conducted a study on bioplastics from cassava. Acid hydrolysis and addition of plasticizer has been also used to come up with a bioplastic. They evaluated the bioplastic in terms of color, odor, and texture. Gupta and his co-researchers said that the use of biodegradable materials will contribute to the sustainability and reduction in the environmental impact associated with disposal of oil-based polymers. This is why the researchers chose to make biodegradable plastics. In his article on bioplastics, he used potatoes to produce biodegradable plastics. The researchers chose to use sweet potatoes since it is starchy. Raman's study showed that acid hydrolysis is one of the methods of improving the functional properties of native starch. Plasticizers are added to some types of plastic to make them more flexible. Hence, the researchers used plasticizers in making biodegradable plastics.
Good day everyone, I am Sydney Aguba and I will be reporting the chapter 2 of this study. Collection of sweet potato and the extraction of starch.
2 kilograms of fresh sweet potatoes were obtained from the Kalayaan market. The selection of the sweet potatoes was done randomly using the lottery method. The sweet potatoes were then washed with tap water, peeled and juiced in a blender. When the sweet potatoes were already finely blended, these were placed in a cheesecloth and squeezed to get the filtered juice of the sweet potatoes. The extracted juice was left aside in a bowl in order to allow the starch to fully settle at the bottom. After an hour, the liquid was separated from the starch using decantation.
Cooking the mixture of biodegradable plastic.
In a saucepan, the following were added one at a time: 1 tablespoon of the extracted sweet potato starch, 7 tablespoons of tap water, 2 tablespoons of vinegar, and 2 teaspoons of glycerine or propane 123 triol. The mixture was then cooked in medium heat and stirred constantly. When the mixture thickened into a plastic-like paste, it was poured from a saucepan to a flat glass chopping board. It was then left to air dry for 3 to 5 days until the mixture completely dried and hardened.
Product evaluation. Biodegradability, color,
Elasticity and tensile strength,
texture,
and stain resistance were assessed by the researchers.
color and texture were assessed through sensory evaluation. Readability test, the samples were placed on the soil. Data was gathered for 2 weeks. These samples were then assessed by sensory evaluation.
The researchers performed the stain resistance test by soaking the produced bioplastic in a bowl of mustard, a strong staining agent, and was placed in an oven at 37 Celsius for 24 hours. To accurately measure the color of the part itself, both before and after the staining procedure, a colorimeter was used. A colorimeter is a device used for measuring colors, or colorimetry. It measures the absorbance of different wavelengths of light. Elasticity and tensile strength were done simultaneously. Using a spring balance, each sample was then tested. Each sample was composed of 3 trials. The initial length of each bioplastic will be measured first. The cross-sectional area of each bioplastic was measured using a vernier caliper. While stress is being exerted on the bioplastic, the length of elongation in centimeters was measured before it will break, using a ruler for elasticity and the amount of force exerted for tensile strength.